Good morning, students. Today we are going to see this third subtopic of Unit 3, Drivers of Climate Change, Climate Sensitivity and Feedbacks, the Montreal Protocol. Introduction to drivers of climate change. The Earth climate system is influenced by multiple factors that alter its energy balance known as the climate change drivers. So the Earth climate system is not only affected by a single factor, it's a multiple factor. These include natural processes such as volcanic activity, solar variation, and ozone circulation, as well as human driven changes. So the climate change is not only because of the human activities, it is also by means of the natural means. For example, the volcanic activity. The volcanic activity, even the human lives in a uncivilized situation. Just imagine during that period, for example, 500 years back or 200, 2000 years back, that time also it's naturally the volcanic eruption happens. But after industrialization, what happens? Lot of carbon footprint increases. Okay, because of that, it could be able to entrap the heat and reflect back again the heat to the atmosphere, which causes the increase in temperature of around 1.8 degrees Celsius per year. So this include not only by natural process, not only by human activities, is also by means of the natural process. Human activities have increasingly dominated in recent centuries, particularly through greenhouse gas emissions and land use change. Understanding these drivers is essential to explain observed climate shift and predict future impact with greater accuracy. So, understanding these drivers is essential to explain about the observed climate shift. So, this is necessary in order to understand why this shift has been happened. That means increase in temperature. That's what they mean. Understanding these drivers is essential to explain observed climate shift and predict the future impact with greater accuracy. Primary drivers, atmospheric concentration, changes in greenhouse gas and aerosol concentration, land cover, and solar radiation directly influence the climate. So, what are the things? Changes in greenhouse gas and aerosol concentration. What is aerosol? Aerosol is nothing but a suspended matter or is a particle which has been suspended in the air due to man-made activities, or it may be a um, natural one. And there are natural aerosol and the man, because of the man-made activities, okay, the aerosol may produce. Okay, so these are the things: changes in greenhouse gas and aerosol concentration, land cover, and solar radiation indirectly in the influence the climate. These factors determine how radiation is absorbed, reflected, or emitted in the atmosphere and at Earth's surface. The net energy balance change from these influences is measured as radiative forcing. Underline the word radiative forcing. Radiative forcing is a key concept for comparing the warming or cooling effects of different climate drivers globally. So, in a broader perspective, what is radiative forcing? Okay, I will tell you what is radiative forcing. Radiative forcing is nothing but is a measure of change in earth energy balance caused by a factor like greenhouse gases or aerosols. It is a measure of change in earth energy balance caused by a factor like greenhouse gases or aerosols that alters the amount of incoming solar radiation and outgoing infrared radiation. So it is a measure of change in earth energy balance. So that is nothing but it is a measure of change in net energy balance. Earth energy balance. A positive radiative forcing indicates warming effect, more energy entering than leaving, while a negative radiative forcing indicates a cooling effect, more energy leaving than entering. It is measured in watts per square meter. So energy imbalance, radiative forcing quantities quantifies the difference between the incoming solar radiation and outgoing infrared radiation from Earth. There are two things, one is positive forcing and another one is negative forcing. Positive forcing leads to warming. For example, increased concentration of greenhouse gases like carbon dioxide trap more heat, resulting in a positive radiation forcing. Negative radiative forcing leads to cooling. For example, some aerosols can reflect sunlight back into space, causing a negative radiative forcing. What are the factors which are influencing the radiative forcing? Greenhouse gases, aerosols, solar irradiations, and surface albedo. What do you mean by surface albedo? Changes in the reflectivity of Earth's surface due to deforestation or ice melt can affect the radio radiative forcing. Okay, so the net energy balance change from these influences is measured as a radiative forcing. Greenhouse gases definition and types. Greenhouse gases are atmospheric components that absorb and emit infrared radiation, creating the greenhouse effect. Key natural and anthropogenic greenhouse gases include water vapor, carbon dioxide, methane, nitrous oxide, and ozone. We know already the greenhouse gases. Human made greenhouse gases such as halocarbons are entirely industrial in origin. So the halocarbons is not in natural, it is a human made greenhouse gases. Under the Kyoto Protocol, priority gases include carbon dioxide, methane, nitrous oxide, hydrofluorocarbons plus perfluorocarbons. PFCs is a perfluorocarbons and SFS, SFS is the sulfur hexafluoride. Okay, so or due to their high warming potential. So periodic gases include these gases due to their high warming potential. So what is PFCs and SF6? A small introduction I just would like to say. Okay, PFCs is nothing but perfluorocarbons. SF6 is a sulfur hexafluoride compound are both potent greenhouse gases, but they differ in sources, uses, and some of their impacts. PFCs are synthetic compounds primarily used in various industrial and commercial applications like fire protection, non-stick coatings, and electronics manufacturing. SF6 is predominantly used as an electrical insulator in high voltage equipment. Both gases have long atmospheric lifetime and contribute significantly to global warming. Anthropogenic greenhouse gas emissions, which happened between 1970 and 2004, human caused greenhouse emissions rose by 75%. Okay, that means between 17 to 2004, almost 34 years, human caused greenhouse gas emission rose by 75%, 70% with carbon dioxide up by 80%. Okay, burning fossil fuels is the primary source of carbon dioxide. That we everyone will agree. Followed by deforestation. Methane emissions stem from fossil fuels, agriculture, and livestock, while nitrous oxide come largely from the agriculture. Rising concentration of these gases intensify the greenhouse effect and shift the global radiative balance toward warming. So, radiative forcing and global warming potentials. What is global warming potential? It is a measure of relative warming effect of gas compared to carbon dioxide over a set period. Since 1970, human activities have produced a net warming effect of 1.6 watts per meter square in radiative forcing. Human activities only have produced a net warming effect. Almost it will increase the warming effect of positive 1.6 watts per meter square in radiative forcing. Radiative forcing helps compare the climate impact of different gases or activities. And also the global warming potential is a measure of relative warming effect of a gas compared to carbon dioxide over a set period. Greenhouse potential accounts for gas absorption strength, absorption wavelength, and atmospheric lifetime, though it remains a simplified index. Warming potential of key greenhouse gases. Methane as a greenhouse potential GWP, green warming potential, 25 times that of the carbon dioxide over a 100-year period, meaning traps 25 times more heat per kilogram. Methane has a green green warming potential 25 times that of the carbon dioxide. So we global warming potential. Okay, global warming potential is almost when compared to carbon dioxide, it is methane is 25 times stronger. Methane has a global warming potential 25 times that of the carbon dioxide. It's dangerous. Nitrous oxide has a even higher global warming potential, about 298 times, almost 300 times stronger than the carbon dioxide. Industrial gases like sulfur, hexafluoride are thousands of times more potent than compared to the carbon dioxide. So carbon dioxide only is not actually more effective. When compared to carbon dioxide, 25 times stronger than the methane and 300 times stronger nitrous oxide, 1000 times stronger in sulfur hexafluoride. These large differences in global warming potential highlight the need to manage the high impact gases even if they are emitted in smaller quantities. Carbon dioxide, the role of carbon dioxide. The carbon dioxide is the most significant long-lived greenhouse gas emitted by human activities. It remains in the atmosphere for centuries, making it critical for long-term climate change. It's very simple. So I just read it out. Okay, hope you understood the meaning of this sentence. This is self-explanatory, right? The primary sources is fossil fuel combustion, followed by deforestation and industrial processes. Although less potent per molecule than methane or nitrous oxide, its massive volume makes it the largest driver of warming. Why? Even though this more global warming potential is lower when compared to the nitrous oxide and um, SF6, okay, sulfur hexafluoride. This, although less potent for per molecule than methane or nitrous oxide, its massive volume makes it the largest driver of warming. That's why this in with respect to carbon dioxide we are just talking, right? The role of methane is emitted from natural sources like wetlands and human sources such as agriculture, fossil fuel extraction and waste. So this methane even by natural means, okay, it will happen even in the, if there is no industrialization, even vegetation or what do you call it, from the agriculture, the methane, large quantity of methane will produce, and the decomposition of thing biogas, okay, methane will produce. Okay, so this all is even by natural means this may be emitted, but what happens because of the human activities, this concentration is further increasing. The planet could not able to regain its position. That means sustainability is not maintained. Okay, so it is. That's why we are all talking about this climate change. It is far more effective than carbon dioxide at trapping heat in the short term. It is far more effective than carbon dioxide. Okay, just imagine how many global warming potential. Okay, methane. Methane's lifetime in the atmosphere is about 12 years, shorter than the carbon dioxide, but its high global warming potential makes it crucial in near-term warming. Okay, reducing the methane can have a rapid benefits for slowing climate change. Roles of nitrous oxide. Nitrous oxide is produced mainly from agriculture soil management, fertilizers, and livestock waste. It is also emitted during industrial activities and fossil fuel combustion. Nitrous oxide not only warms the atmosphere but also depletes the ozone layer. With a long atmospheric lifetime, 100 14 years, it remains a persistent contributor to climate change after emission. Halocarbons and other industrial gases. Halocarbons include CFCs, chlorofluorocarbons, hydrochlorofluorocarbons, HFCs, and related compounds, most of which are entirely human made. Many are used as refrigerants, propellants, and solvents. They have very high global warming potentials, sometimes exceeding 10,000 times that of the carbon dioxide. So just CF to Cl2, difluorocarbon. Imagine it has been used as a refrigerant. I told you in the previous classes also during the video. This has been widely used as a refrigerant some long back. Now, after it has been found is a ozone depleting compounds, it has been stopped, and then the people have been started to use the liquid ammonia. Okay, so otherwise, what will happen? The ozone, the good ozone O3 has been depleted into ozone and decent oxygen. because of the usage of hydrofluorocarbons. So once the ozone layer has been become old, what happens? The radiation will easily can penetrate into the thing, and the human will be affected with the different types of diseases because of the UV radiation. Okay, it will filter the UV radiation of the ozone layer. So these are the things need to be considered, and also these chlorofluorocarbons also will have a high having a global warming potential, sometimes exceeding the 10,000 times that of the carbon dioxide. Okay, while some have been phased out due to ozone depleting concerns, replacement can still have a strong warming effect. I didn't see actually this one. Did you see? As I told you, while some have been phased out due to ozone phased out, that means have been removed because of the ozone depletion concerns. Replacement can still have a strong warming effects. Aerosols as climate drivers. Aerosols are tiny particles or droplets suspended in the atmosphere from natural and human sources. Natural sources include dust storms, sea spray, and volcanic eruptions. Anthropogenic aerosols arise from burning fossil fuels, biomass, and industrial processes. Aerosols can cool the earth by reflecting the sunlight or warm it by absorbing radiation depending on the type. Cooling effects of aerosols. Sulfate aerosols from coal burning strongly reflect the sunlight, creating a cooling effect. This cooling property offsets the warming from greenhouse gases. However, aerosol particles have strong lifetimes in the atmosphere, meaning their cooling influence is temporary. Reducing the aerosols without cutting greenhouse gases could unintentionally speed up the warming. So the cooling effects of aerosols that we have seen. Now the warming effects of aerosols. Black carbon from incomplete combustion absorbs sunlight, heating the atmosphere. So black carbon soot from incomplete combustion. Automobile, just imagine. Okay, the dust particles, the aerosols may be generated. Okay, not only that, for even from industrialization, so even after industrialization, lot of dust has been emitted through the chimney. Okay, that also need to be considered, which all will affect the increase in temperature. Aerosols will have a cooling effects as well as the heating effects. Deposits of black carbon on snow and ice reduce reflectivity, albedo. Okay, reduced reflectivity, albedo, accelerating the melting. Organic carbon aerosols can also absorb some radiation depending on composition. Overall, aerosol impacts on climate are complex and can vary by region and particle type. Land cover challenge and climate. Human driven changes like deforestation, urbanization, and agriculture alter the earth's surface properties. Okay, human made activities like deforestation, so removal of trees, okay, plants, okay, urbanization, construction of building, okay, iris building, and the usage of concrete and industrialization. Urbanization is also include the industrialization and agriculture alter the earth's surface properties. Deforestation reduces carbon storage and changes albedo, often warming the local and global climate. Urban heat in islands develop as cities replace vegetation with heat absorbing materials. Urban heat islands. So urban heat islands develop as cities. Okay, just imagine a lot of cities have been growing. Okay, replace the vegetation with heat absorbing materials. Land cover changes also impact evapotranspiration. Evaporation and transpiration is a photosynthesis process. The carbon dioxide has been taken by the plant, and what you call the oxygen has been left out by leave out by the plant or trees, influencing local weather patterns. So land cover changes also impact the evapotranspiration. Solar radiation changes. Variation in solar energy reaching Earth influence climate over short and long time scales. Sunspot cycles create small but measurable changes in solar radiation. Over the past century, solar changes have been more minor compared to human influences. Solar variations are still important for understanding the natural climate variability in paleoclimate records. What is paleoclimate records? Do you have any idea? Hope you understood so far what has been taught to you. If you are not clear during the face-to-face section, please comment, meet me and clarify your doubts. Okay, coming back to your paleoclimate records. Paleoclimate records are natural archives that provide information about past climate, extending our understanding of Earth climate far beyond the instrumental record. This records found in three rings: ice cores, corals, and lake and ocean sediments offer insights into past temperatures, precipitation, and other climate variations. By studying these archives, scientists can better understand the natural climate variability and the impact of climate change. So, the paleoclimate records are nothing but a natural archive that provide information about the past climate. Paleoclimate records are essential natural archives that store information about past climates. They offer a glimpse into Earth climate history, extending our knowledge beyond the period covered by instrumental measurements. These records are crucial for understanding how the climate system has behaved under different conditions and for evaluating the performance of climate models. So, various natural archives provide paleoclimate information. One is three rings, another in ice cores, corals, and ozone and lake sediments and speleothems. Okay, we will go one by one. Tree rings. The width and density of tree rings can reveal the information about past temperatures and precipitation, with wider rings often indicating the wetter or warmer conditions. Ice cores extracted from glaciers and ice sheets contain trapped air bubbles that reveal past atmospheric composition, including greenhouse gas concentration and layers of ice that provide information about past temperature and snowfall. Corals. Coral skeletons grow incrementally and their composition can reflect past ocean temperature and salinity. Ozone and lake sediments. Layers of sediments accumulate over time, preserving pollen, fossils, and other materials that can be analyzed to reconstruct past environmental conditions. Speleothems, stalactites and stalagmites in caves can record past rainfall and temperature variation through their chemical composition. So it is nothing but a past information. Okay, the paleoclimate records are natural archives that provide information about past climate. Okay, coming to the volcanic activity and climate, large volcanic eruptions inject massive amount of aerosols into the stratosphere. So when I visited Indonesia, I could able to see a lot of volcanoes. Okay, that means from one side of the location. Okay, and it has been with a dark spot on the slope of the hill. I could able to see a very dark black because of the volcanic eruption which happened 10 years back or 15 years back. Okay, so large volcanic eruption inject massive amount of aerosols. Okay, these aerosols reflect sunlight, temporarily cooling earth's surface for 1 to 3 years. Volcanoes also emit carbon dioxide, but in much smaller amount than human activities. Examples include Mount Pinatubo, which caused a global temperature drop of 0.5 degrees Celsius. Ozone circulation and climate variability. Ozone currents redistribute heat across the globe, influencing climate patterns. Changes in circulation, such as ENSO events like El Nino and La Nino, affect the temperature and rainfall globally. The thermohaline circulation, ozone conveyor belt, moves warm and cold water between the poles and tropics. So the ENSO events, because of the heat radiation, the surface sea water will move from the one phase to the other phase. That is from the equator to the Arctic, or from the Arctic to the thing. Because of that, the wind circulation happens. That's what we have seen in the unit 1. Disruption in circulation could cause a significant regional climate shift. The interplay of natural and human drivers, both natural and anthropogenic factors, operate together to shape climate outcomes. Natural drivers explain historical variability but cannot account for the recent warming trend. Human activities now dominate the overall radiative forcing balance. Climate models incorporating both drivers provide the best match to observed changes. Evidence for human influence. Observations shows rising greenhouse gas levels closely match human emissions since the industrial revolution. Isotopes analysis like atmospheric carbon dioxide to fossil fuel combustion, warming patterns in the troposphere and cooling in the stratosphere align with the greenhouse gas driven changes. The IPC states with high confidence that human activities are the main cause of reason warming. Okay, the IPC clearly states that with high confidence that human activities are the main cause for the reason warming. So, however, the natural also will contribute, but the global warming is mainly due to the human activities. Okay, so that's why the IPC says. So, IPC Intergovernmental Panel on Climate Change. So why it was created? IPCC was created to provide the policymakers with the regular scientific assessment on climate change, its implication and potential future risk, as well as to put forward the adaptation and mitigation options. Okay, the role of climate feedbacks. The feedback process can amplify or dampen the climate change effects. The positive feedbacks like ice albedo feedback accelerating the warming. So now I just would like to explain the ice albedo feedback. So ice albedo feedback is a process where changes in ice or snow cover affect the Earth's reflectivity, leading to further temperature changes and influencing the extent of ice and snow. What is ice albedo feedback? It is a process where changes in the ice or snow cover affect the Earth reflectivity, leading to further temperature changes, influencing the extent of ice and snow. Ice albedo effect. Negative feedback such as increased cloud cover can slow warming. Understanding the feedback is key to predicting the full impact of climate drivers. As albedo feedback, ice and snow reflect most incoming solar radiation. Warming causes melting, reducing the reflective surface and exposing the darker brown or water. This darker surface will absorb more heat, causing further warming and melting. This is a strong positive feedback in polar and glacier regions. Water vapor feedback. Warmer air holds more water vapor. Warmer air holds more water vapor, which itself is a greenhouse gas. This increases the greenhouse effect and amplifies the warming. Cloud formation from water vapor can cause both cooling and warming effects. Water vapor feedback is considered one of the most powerful climate amplifiers. Water vapor feedback is considered one of the most powerful climate amplifiers. Carbon cycle feedback. Climate change can alter the carbon sinks like forests and ozones. Warming may reduce the carbon uptake by soils and vegetation. Melting permafrost can release methane and carbon dioxide, increasing the greenhouse gas concentrations. Such feedstock can make it harder to limit the global temperature rise. Ozone atmosphere carbon exchange. Ozones absorb about 25% of human carbon dioxide emissions every year. Warmer water holds less carbon dioxide, reducing ozone uptake over time. Acidification from carbon dioxide absorption threatens marine ecosystem and carbon storage capacity. Let's say you have a lot of carbon dioxide. When it has been contacted with the ozone, what will ozone? I mean, the seawater. What happened? It will form a carbonic acid. Acidification from carbon dioxide absorption threatens the marine ecosystem because the ecosystem also is getting affected because of the greenhouse gases. Because not only by increase in climate, because of the other side effects like the carbonic acid formation when it has been contacted with the seawater, and even in the precipitation and acid rain, this all causes the ecosystem. Changes in ozone circulation may also affect the carbon exchange rates. Short-lived climate pollutants. So what do you mean by short-lived climate pollutants? Short-lived climate pollutants include methane, black carbon, and some hydrofluorocarbons. They have strong warming effect but remain in the atmosphere for a short time. Cutting short-lived climate pollutant emissions can yield quick climate benefit and improve air quality. Addressing short-lived climate pollutants is a complement, not a substitute for reducing the long-lived greenhouse gas emissions. Long-lived climate pollutants, carbon dioxide, nitrous oxide, and many halocarbons persist for decades to millennium, from years up to 10 years to 100 years. Okay, the cumulative millennia. Okay, so not century, millennia. 21st century or millennia is a millennium. Okay, just imagine many years. The cumulative effects drive long-term warming trends. Even if emissions stop today, past emissions would continue to warm the planet. Mitigation must focus on both short and long-lived pollutants for lasting results. Anthropogenic versus natural radioactive forcing. Natural forcing today is relatively small compared to anthropogenic forcing. Human induced forcing from greenhouse gases is more than 10 times greater than the solar changes. Aerosols from human activity also alter the cloud formation and sunlight reflection. So, if the cloud formation and everything changes, obviously the rainfall will affect, the pattern will change. Okay, the separating these effects is crucial for accurate climate modeling. Okay, climate models and attribution studies. Climate models simulate Earth climate system using physical laws. Attribution studies compare simulation with and without human influences. Models with only natural drivers cannot reproduce recent warming. So, including anthropogenic drivers matches the observed pattern, confirming the human impact. So, model with the natural drivers. So, because of the natural activity, how the climate cannot reproduce the recent warming. So, we could not able to justify the increase in temperature by only by the natural drivers. Okay, we also need to include the anthropogenic drivers. That means because of the human activities, how this increase in temperature happens. Then only you could be able to model it. Including anthropogenic drivers matches observed patterns and confirming the human impact. Policy implication of climate drivers. Identifying the major climate drivers helps prioritize mitigation action. Policies targeting high global warming potential gases can achieve faster warming reduction. Land use planning can reduce emissions and increase carbon storage. International agreements like the Paris Accord rely on understanding the driver impact. So, what is today's takeaway for you is that climate change results from a mix of natural and human drivers. That is because of the natural and human sources, but human influence now dominates. Greenhouse gases are the most significant anthropogenic driver, followed by the land use changes and aerosols. Feedback processes can accelerate the changes, making early action critical. Understanding the drivers enables informed decision making for climate policy and adaptation strategies. With this note, I try to conclude today's section. We have another two subunit. Okay, I think three subunit to complete to the unit two. We will shortly will complete. Thank you.